Good day, good day, good day. Welcome back to our YouTube channel. If you're new here, welcome. I hope we are going to have a great time while we are doing vertical projectile. Now we are focusing on calculations. Since the last episode, I focused a lot on the theory and also most important stuff that you can use to do the calculations. So now we are going to apply everything that I talked about in the previous section. Let's just get straight into it. So we are having a question here that is saying a ball is dropped from a building which is 50 meters high. Calculate the ball's velocity just as it hits the ground. So what's going to happen now? I'm going to answer 4 questions that are simple like that. I just took them from a simple textbook that are simple, and then the rest of the questions, I think there are 5 or 6, I have screenshotted the question papers and I made a PDF on that. If you want the PDF, the link is in the description of this video, so you can check the description there. You find a Google Drive link, then you can download that PDF so that you can work on it after we are done with this. So we're having a question here. So what you have to do is first you make a diagram of your own that is representing everything that they just gave us here. So we're having a building which is 50 meters and they said a ball is dropped. So it means that we're having a ball here. It is dropped from that building and it is going down, right? So we can name this A and we can name this B, right? So the initial velocity there, or the velocity at point A, is equals to 0. Since we said if anything is dropped or if anything is released, its velocity is 0. So if you haven't watched this, please go back to lesson 1 on vertical projectile and you can watch all the important stuff that can help you to do the calculations. So we want the velocity at this point. So this is, since we're having the motion from A to B, so this is our initial and that will be our final. So I advised you to make a diagram of your own and also to make a list of your own of everything that you are given and everything that you can conclude from everything that you are given. And also you need to write down what you are not given and that you want to find, right? So according to this question, we are having the initial velocity as 0. We're having the acceleration as 9.8. We're having the displacement of the ball from this point to this point as 50 meters. So since we are going to be dealing with vectors, it's wise to choose the direction. So since we are talking about upwards and downwards motion, so I'm going to take my downwards as positive, right? So it means that upwards will be negative when we're doing the calculations. So since the acceleration is always downwards, so it means that my acceleration is a positive 1. Since the displacement is going downwards, it will be a positive 1. And now we are looking for the final velocity, which is unknown at this moment. So we are trying to find the final velocity or the velocity at point B. So now let's look at our equations of motion there to see which one best suits this. So VF, we're looking for it. Initial velocity we have, acceleration we have, but we don't have time, so we cannot use this. So this one, final velocity, we are looking for that. Initial velocity, it is 0. Acceleration we have and displacement we have. So it means that we can use equation number 2 there, right? So first thing first, we just write the equation. So Vf squared is equals to V initial squared plus 2 acceleration and change in y. So we are using change in y because this is a vertical motion, right? So our Vf squared becomes our V initial as 0 plus 2 9.8 and the displacement is 50. So our VF squared becomes 2 multiplied by 9.8 is 19.6, multiplied by 50, that's 980, and we can square root both sides. So it means that now our final velocity, it will be, so the square root of that, you can use a calculator. So we find that it is plus or minus 31.30, right? But since this thing is going downwards at that moment, so it means that our final velocity will be plus 31.30, which is the same as 31.30 meters per second downwards. So that's how we can calculate that. So let's move to the second question. So on the second question, they said a ball is projected vertically upwards at 20 meters per second. Calculate the maximum height the ball will reach. So obviously it means that this ball is projected from somewhere going upwards, and the velocity here, it is 20 meters per second. So they need the maximum height that the ball will reach. So we need the maximum height that this ball will reach, right? So let's write down whatever that we know. So we are having our initial velocity as 20 meters per second. But you can see that this is going upwards, and already we said we are going to take downwards as positive in these videos, right? So it means that this becomes negative, right? And also this is going upwards, so it means that our displacement will become a negative something. Is that something we are trying to find, right? Because it is going upwards. And our acceleration is always 9.8 meters per square second downwards, so it has to be positive. So our final velocity will be what? So we said it is reaching the maximum height. So in the previous video I explained that at the maximum height the velocity is 0. So our velocity there, it will be 0. So we are taking this as our initial, that is our final. So which formula can we use? So also we can use the second one, since we are having the final velocity, the initial velocity, the acceleration, and we are trying to find the displacement. So now it will mean that our Vf squared is equal to our V initial squared plus 2 acceleration changing y. So our final velocity is 0, so 0 squared, and initial velocity there, it is negative 20 squared plus 2, and our acceleration is 9.8 multiplied by the displacement. So now what can we do next? It means that now it's left for us to calculate. So 0 will be equals to 400 plus 19.6 changing y. So we can take this side, so negative 19.6 will become equal to 400. And you can divide both sides by negative 19.6 divided by negative 19.6. So punching that in the calculator, we can see that our displacement is negative 20.41 meters. So what will that mean to us if it is negative? It will mean that our object is going upwards, right? So it means that our maximum height will be equals to 20.41 meters upwards. Just as simple as that. So let's move to another question as well. So we are having another question there, number 3, number 4. So they said a stone is dropped off a bridge and strikes the water below. So if we're having a diagram, so we can say this is dropped and it hits the water below. Afterward, so our time is 5 seconds. So already we know that our time that it took to move from A to B, it is 5 seconds. And also we know that our initial velocity is 0 since it was dropped. It was dropped. So anything that is dropped, the initial velocity is 0. So these are the only, okay, we also know the acceleration, which is 9.8, which is positive because we are taking our down as positive. So our acceleration is 9.8 like that. So question number 3, they said calculate the vertical distance that the stone fell. So we need the displacement. So we need this displacement. So let's take a look at our equations and see which one we can use. So obviously the first one cannot work because we don't have displacement. The second one, we don't have final velocity, but it has displacement. So the third one, we have displacement here, initial velocity, yes we have, time we have, acceleration we have. So we can use the third equation there. So first thing, let's write it off. So working on number 3, we said displacement is equals to V initial change in time plus half acceleration change in time squared. So our initial velocity is 0 multiplied by time, which is 5 seconds, plus half acceleration being 9.8. Since it's going downwards, it's positive, and then change in time, so 5 squared. So now doing the calculations, we can see that our change in y becomes 0 plus 4,9 multiplied by 25. So 4,5 multiplied by 25 will give us 122,5. So our displacement becomes 122,5 meters. So it means that this, since it is positive, it means that it was going downwards. So our displacement is 122,5 meters downwards. Downwards. So our displacement, we found that it is 122,5 meters. Going where? Downwards. So we've worked with number 3. Let's go to number 4. So number 4 is saying find the velocity at which the stone hits the water. So now we are trying to find the final velocity now. So let's take a look at our equations. So this one is saying final velocity, which we are trying to find. Initial velocity we have, acceleration we also have, and time we have. So it means that we can use the first equation, right? So simply Vf is equals to V initial plus acceleration change in time. So our final velocity becomes 0 plus 9.8, and our time is 5 seconds. So which our final velocity can be 9.8 multiplied by 5, which we get 47,5 meters per second downwards, like that. As simple as that. So I hope you enjoyed, and I hope you are enjoying watching this. So now let's move on to the questions that are on the link that I provided there in the description. You can just download it before we can begin with this video. Just go to description and you see a link, Google Drive link. You can get on that and you can download that PDF and you can work on those questions. Let's get straight to it. So I've seen that the time length on this video is already way past 10 minutes, right? So what I'm going to do is I'm going to leave the screenshot at the end of this video so that you can be checking these questions, and on the next video that I'm going to make, I'm going to do those questions on that PDF, right? So at the moment you can try to work them out, try to see your potential on how you are doing on this, right? So when I come back with these answers to this or the solutions to these screenshots, it means that you will be doing the corrections, and also it will help you to recognize where you are going wrong and also where you didn't see what's going on, right? So if you haven't subscribed, please subscribe to our YouTube channel, as that will help us. The more we see a lot of subscribers, the more we'll keep on making videos to make you learn. Until then, see you on the next one. Have a lovely day.